So let's take a look at another question regarding calculating the instantaneous rate of change. We want to find the coordinates of the point on the curve f of x is equal to 3x squared minus 4x, where the tangent is parallel to the line y is equal to 8x, right? So we know that if two lines are parallel, that means that they have the same slope. So if the slope of the tangent is, if the tangent is parallel to this equation, y is equal to 8x, and if we look at the equation of a line as y is equal to mx plus b, right? In this case, the slope here is 8. So the slope of the tangent should be 8, right? Should be the same. So if the slope of the tangent is 8, we want to figure out what the coordinate's going to be, right? When the slope of the tangent is 8. To do that, we're going to find the equation of the tangent. Okay, so to find the equation of the tangent, I'm going to find f prime of x, right? This is the instantaneous rate of change function. And in the case of the instantaneous rate of change function, I'm going to use the first principle. I'm going to use limit h approaches 0, f of x plus h minus f of x, and this is over h. Okay. Now if I apply this, f of x plus h is basically equal to 3 times x plus h squared minus 4 times x plus h. Right, I'm going to use the a plus b squared template, which is going to be a squared plus 2ab plus b squared. So this expanded version here is going to look like 3 times x squared plus 2xh plus h squared minus, if I use distributive property, I get minus 4x minus 4h, right? So if I expand this out further, using distributive property, you get 3x squared plus 6xh plus 3h squared minus 4x minus 4h, right? And you can see that there's no like terms, so I'm not going to be able to collect any of these guys. So that's my expanded form of f of x plus h. Now we also have negative f of x, right? So for negative f of x, I'm just going to kind of create a divide here. For negative f of x, we're going to apply the negative to the outside of the function f of x, so we get 3x squared minus 4x, right? If I apply the negative, pretend there's like a negative 1, and you're distributing that negative 1, you're multiplying it out to the inner terms. You basically get negative 3x squared plus 4x, right? So this is the negative f of x term, and basically f of x plus h minus f of x is equal to 3x squared plus 6xh plus 3h squared minus 4x minus 4h minus 3x squared plus 4x. Okay, and you can see that if you collect the like terms, the 3x squared and the 3x squared here cancel out. Negative 4x and the positive 4x cancel out, right? Because they're equal but opposite terms. And you can see that your numerator, f of x plus h minus f of x, is going to look like 6xh plus 3h squared minus 4h, right? You notice here that in this expression, we can find that h is common. We can factor it out as a common factor. And in this case, you get h times 6x plus 3h minus 4. Okay. Now, if I apply this back to the instantaneous rate of change function, f prime of x, right? This is going to be over h, and limit h approaches 0. You notice here that the h's cancel out, right? Because one of the big things about using the first principle is that when limit h approaches 0, if h is on the denominator, this whole rational expression becomes undefined, right? And we don't want that, so that's where we're canceling the h's out. Now that we have this, my instantaneous rate of change function is going to look like 6x plus 3h minus 4, and I can let h equals 0. So if I let h equals 0, you can see that this middle term cancels out, and the instantaneous rate of change function here is 6x minus 4. Okay? So now that we have the instantaneous rate of change function, we want to figure out the point of x where this instantaneous rate of change function is 8. So the slope of the tangent is 8. So I'm going to let f prime of x equal 8. So you can notice here that 6x minus 4 is equal to 8. If I move the 4 to this side, we get 6x is equal to 12, and therefore x is equal to 2. Okay, so when x is equal to 2, we have an instantaneous rate of change of 8. Now, once I have that figured out, I'm just going to kind of make some space here. When x is equal to 2, we get an instantaneous rate of change of 8. If I want to figure out the full coordinate of that, I want to do f of 2, which is going to give me 3 times 2 squared minus 4 times 2. And you basically get 3 times 4 minus 8, so it's 12 minus 8, which is 4. So f of 2 is 4, so the point is 2 and 4. Okay, so that is my answer.